Hello. In this video, we will try to use the input-output terminals using the graphical user interface. In the previous video, we already explained what are the terminals. Now let us see them one by one. Suppose here you see the constant current source I connected a 1 kilo ohm resistance to ground. That means 1.1 into 1k, around 1.1 volt should be there. So you can see another wire is connected from here to A1 to measure the voltage. And here you can see this A1 is shown here, right? 1.107 volts. Okay. So that means our constant current source is working. So you watch this voltage near the cursor, and if I remove this resistance, then we can see what happens. See, it is showing some high voltage because the resistance is gone, right? That is the reason. And if I just short circuit that to ground, then it goes to 0 volts. So generally the usage is you connect something like a resistive sensor like a PT100 or something to it to measure temperature. That is actual usage of it. So we will not worry about that now. So let us come to this PV1 and PV2. So to measure that, so we will connect PV1. So remove PV1 from here and just connect it in here, and it is PV1 is just connected to A1. So you can see PV1 is connected to A1. And how do we change PV1? So A1 we can monitor here, right? We have put this. See, if I just put this, enable it, it is monitoring. So now you have to remember, whenever I click here, this picture will vanish because this window will come into the focus. So I'll just connect, say set the PV1 to some voltage. Say I set it to 2 volts. Setting it to 2 volts, and you can see here, right? This is becoming 2 volts. So I can also make changes like using this slider like this here. Okay. This is also a possible. When you change this voltage will change. So probably we can connect another wire from say PV2. So you have to see this, whatever connection. So PV2 to, so A2 I connect another wire, right? So now if you come here, you enable A2 also. So the wire is connected, you have seen, so we don't need to see that now. So now we just ask what is A2 here, and then you change this voltage, say change it to something like say -1, right? You can see it here. So this is shown here actually what is your setting, and this is what A2 is reading. So if I remove this wire, let's see, you can see that A1 is gone, right? See, A1 voltage is gone. Now if I reconnect it, it has come back to 2.3 volts. So this is, one is the actual measurement, this is what you set. So only if the wire is connected, you are going to see it here. So that is how the P1, P2 are used. Now we go quickly to the square wave generator, SQ1. So we will just take this SQ1 is connected to A1, and now we have to set SQ1. So SQ1 is at 0 hertz now, and 0 hertz always set it to high, so it is at 5 volts sitting there. So let us set this to something like say 500 hertz. So you can see it is changing here, right? So now I have to change the time base a little bit, because 500 hertz means 2 millisecond is 1 cycle, right? So but you can see here there is some issue, this trace is not stable. So anyone who has used the oscilloscope, they know that you have to set the trigger level, then trigger level should be between the available voltages, like this 0 to 5. So you have to slightly increase the trigger level, it will become stable. And we don't have anything on A2, so we don't have to display that either. So here you can see your square wave coming in. Square wave now it is 50% duty cycle, high and low are equal, but you can change that. See, now it is 20% duty cycle, right? So this is the control you have on square 1, and square 2 we will leave for the time being, because square 2 will come up as an option of waveform generator. So let us go and see what is OD1, digital output. It may look like a very simple feature. See, OD1, I just connected OD1 to A1, okay? So then I come here and set OD1 to high. This goes to high, right? And if I just disable this, again come to, so it will go from 0 to 5 volt. That's all it does, okay? And you also remember A1 is set to 4 volt, so it is exceeding. Actually we should set it to an 8 volt range to see this one proper, because this is the USB supply. You can see it is not, I mean, it has some noise. This is really your USB supply that you are seeing at the high, okay? So that is OD1. Now we go for the most important feature, that is our waveform generator. We have to make a connection here. See, waveform generator. So we don't need this wire, so only one wire, okay? So here you can see this WG is connected to A1, and already a sine wave is there, because by default it is coming in a 1 kilohertz. So but here we can go back to our 4 volts. So now what you can do here, you can change the amplitude. Say you can make it 1 volt, or you can even make it very small, like an 80 millivolt, or we go back to 3 volt. So this is the waveform generator. The frequency is okay, WG frequency we have not set it, because when you switch it on, it comes back to 1 kilohertz. So let me make it something like, say, 500 hertz. So it is a 500 hertz. Now I can tick this and measure the frequency here, okay? Only for sine wave this measurement will be correct, because it is a mathematical fit. Now I can change this sinusoidal into a triangular wave, and also you can set a square wave on this, but then you will find a message here, output has gone from this to SQ2. So you have to change the connection to view it. See, square wave, 500 square wave is set on. So SQ2 is as an option of WG, okay? So WG there is nothing, but again if you come back to sinusoid, it will appear here. And now what is in the other WG bar, we can see that also. So WG bar is here, we can connect it to A2. Like if you see here, WG bar is connected to A2, and now we come here and watch this, just out of phase, okay? So if I change it 1 volt, both of them will be again. So it is just an inverted output. Okay, now what less? So this is over. Now we can come for this in one here, right? So in one, I told you, in one is for measuring capacitance. So I should get one small capacitance to connect it there to measure. So let me see if we have some capacitor here. So okay, I can see a small capacitor here. So I'll just try to connect a capacitor from here to. So a capacitor is connected there. Then we come here and say measure capacitance. It says 88 nanofarad. Okay. So it is one capacitor. We can put probably another capacitor now, slightly bigger one. Right, and measure it. It is 908 nanofarads. Okay. So similarly, now we come back to the next one, is in2. I told you in2 is for frequency measurement, right? So we need some frequency. For that we will connect this our square wave SQ1. So we will connect it to A1 as well as into. So it is coming to into and also to A1. Okay. So now you can go and ask what is the frequency on into. It says 500 Hz, 20% duty cycle, right? So it measures the duty cycle. So if I go and change the duty cycle and come back here, repeat the measurement, it measures the duty cycle. So these are very exact measurements. It is very useful when you do the experiment with that 555 IC oscillator and all. So you don't have to put a cursor and measure the duty cycle. This will measure it exactly. So into then next is, as I told you, it is sen, right? The sensor input. So for the just to show how it works, I'll use a 1K resistor connected to the sensor input. But generally what we do is we connect photo transistors and other things there, but this is just for verification. A 1K resistor is connected now. You can see it is sitting there, 1K resistor, and you can see here the resistance, it says 999 ohms. It simply displays the resistance, nothing more. And now if you come to A1 and A2, we don't have to explain it again because we already used A1 and A2. So you can see sine wave is connected to A1 now. We see the waveform here, but we will go a little bit into detail. So here say 3 volt sine wave is coming. So A1 you can select the voltage range. So 16, suppose if you have a 15 volt a transformer output or something connected here, you select this range, maximum range. But I can go and select a 1 volt range, but then what happens, it is complaining your input is clipped, because when you select a 1 volt range and give a 3 volt output, so you have to go to a proper range like any other oscilloscope. Okay. And here if you check this, it will measure the peak voltage and frequency. Basically it is done by a mathematical fit, it is not a actual measurement, no frequency counter or anything. And another thing is you can enable a cursor here, this feature, it will put a vertical cursor, and wherever is that cursor, it will, you are going to get the display. So you can see here time and the value of A1, and if you have more, it is showing for both, right? So A2 there is no output, but if A2 something is there, it will show that voltage also. So if you want to see the value of voltage at the cursor point, you enable the cursor like this, you can see that. So that is one option, and of course the time base and other things you can choose. Okay, it is, you can see that now it is not triggered well, right? That's again is a question of setting the trigger level, and okay, trigger got disabled, that's why. So trigger should be enabled all the time, and you can change the trigger channel. Suppose if I just trigger source, if I give A3, it will jump around because there is no input in A3. So we have to either trigger on A1 or A2, and the trigger level, you see, if I just change the trigger level, it is changing the starting point. You can see where the waveform starts, right? So that is the meaning of the trigger level in any oscilloscope. And then it comes to now other A3, as I told you, it is similar to this. So I will connect this to A3 now, remove this, and let us connect this to A3. So let us watch A3, we don't have anything on A1, A2, A3 is here, right? And then you have to trigger on A3. Now let us make the voltage 80 millivolt. You can see 80 millivolt is very, very small. Even if I go A3 into 0.5, okay, I can somewhat see, but there is an easy way now to amplify this. I can put in our that RG so that it will actually amplify the signal, not setting the limit in software, amplification in software. There will be a real amplification. See? So now A3, even if I put it in 1 volt, and what I see is, you can see our 80 millivolt becomes 830 millivolt, now 0.83 volt, right? So these are the advantages. Okay, so more or less the features we have covered, and only thing left is a microphone. How to connect a microphone? I don't see a microphone here. Let me just see, I have one here, so let me just try connecting a microphone and let's see. So here there is an ordinary condenser mic, and now we have to select that channel, microphone channel. Okay, it takes some signal. If you give some disturbance to that, it is giving some sound, but it is better if we could make some sound source, it would have been better. And let me just try connecting something which can make some sound, hopefully. So I connect a small buzzer to the waveform generator. So you can see here, I am keeping the microphone near this buzzer. Okay, microphone is there near the buzzer. Here. Okay, and now you can see here, we don't need this one, and this voltage given to A1 also should be, let's just connect that. So whatever is connected to the buzzer, we will monitor that on A1. Okay, so now we have A1 also, make it 3 volt. Okay, so this is the applied voltage, and the other one is the microphone output. Okay, so now you will find something interesting. If I just change the distance between them, the phase difference also will change, amplitude also will change. Okay, we will come to that later. So these are roughly the features of expeyes. And now maybe later on we will come and see what all the experiments we can do using this, one by one. So let us stop it here now.